Join me in this episode to get started with the Foxhound Evaluation Board, a versatile platform featuring NXP's UWB indoor positioning technology for IoT applications. Whether you're working on a secure access or an industrial IoT solution, this board simplifies development with Arduino compatibility and embedded software tools. Hi, welcome back to TechVentures. My name is Lazina, and I'm a technical marketing engineer here at Future Electronics. If you're interested in checking out any previous episodes, then please feel free to click the link on the screen or check out the description box below. Foxhound is an evaluation board designed by Future Electronics to showcase NXP's SR150 Ultra-Wideband precise positioning and ranging solution optimized for IoT use cases. At the heart of the board is Murata's Type 2BP, a compact UWB module with NXP's SR150 chipset, clock, filters, and other components. It uses the Arduino form factor, making it compatible with many industry evaluation platforms. The board also includes NXP's SE051W secure element, an OLED display, 8 megabits of flash memory, and built-in PCB antennas. The Foxhound board has two sensors, a Murata magnetic sensor and an NXP 3-axis accelerometer. The accelerometer detects motion and helps save power by putting the UWB module into low power mode when the board is idle and waking it up when movement is detected. The Foxhound board includes embedded software and ready-to-use binary files, making it easy to build, load, and debug firmware, to run demos, and to connect to PC console software like PuTTY or TeraTerm. The evaluation platform can be used for developing industrial IoT applications like secure hands-free physical and logical access control, indoor positioning anchors, smart home control, amongst many others. Today, I'm going to show you how to get started with the Foxhound board. Okay, we'll need a few things. So on the hardware side, we'll need the Foxhound kit. Inside the box, we have two Foxhound shields, which are exclusively available at Future Electronics. And they're attached to two of NXP's Freedom MCX N947 development boards, one for each Foxhound shield. We have two USB Type-C cables. We've got lovely information on the Freedom Development Kit, the user guide, and of course we have jumpers if you need them. And I also wanted to draw attention to the inside of the box where you can find more information on how Foxhound relates to UWB. And moving on the software side, we'll need TeraTerm. All right, we've got everything we need, so let's get started. The hardware is already prepared in the box. The Foxhound shield is aligned with NXP's MCX N947 Freedom board. Just to make sure that nothing has been displaced during shipping, the UWB antennas should face the same direction as the USB-C connectors on the Freedom MCX N947 boards. Next, power on the boards via the USB Type-C connectors on the Freedom MCX N947 board using a USB Type-C cable. Plug one end of the wire to the connector and the other to a power source. Once the boards have been powered on, the OLED display should initialize with the following startup message. It should say Foxhound switch 1 to start. Upon power up, you should see both displays that say Foxhound switch 1 to start on the OLED display. The OLED display will indicate which board acts as a controller and Controlee. Press user button 1 on both boards simultaneously to begin the pairing process. Once paired, the modules will begin displaying data on distance, azimuth, and elevation. So the information that's displayed on the OLED display, you'll see the role, so controller or Controlee. You'll see distance, which is the real-time distance between the paired modules. You'll see the azimuth, which is the angle of arrival azimuth in degrees between modules. And then there's the elevation, and that indicates the angle of arrival for elevation in degrees between modules. And then, of course, if you'd like to reset, press switch 1 on the Freedom MCX 947 board to restart the demo. Please note that the UWB demo will run for 30 minutes. After 30 minutes, a reset of both Freedom boards will be required. The controller, also known as the initiator, initiates communication, while the controlee, also known as the responder, replies with the relevant data such as two-way ranging measurements. The controller is typically stationary, acting as the anchor, and this setup enables features like absolute positioning in RTLS systems with multiple tags. But for the purposes of our demo today, our ecosystem consists of only 2 boards, so it won't really make a difference on which board is stationary. Another way to view the data between the controller and the controlee is to use a terminal program of your choice to open a serial connection. I'm going to use TeraTerm. Open 2 windows, one for each device. You could also just open one COM port as both devices are broadcasting the same information. To get rid of the gibberish, we need to set our serial port settings. So as always, we set it to 115200 for the baud rate, and 8 bits for data, no parity, and 1 stop bit. I just hit reset on the MCX boards so that I can get a fresh start on my terminal screen. So at the start of the demo, I can see the device name, firmware version, middleware version, if that kind of information is interesting to you. And all the green numbers here represent the payload being sent and received between the 2 Foxhounds. If you were wondering what TMLUWB stands for, it stands for the transport mapping layer of the UWB. Totally obvious, right? The measurement for distance between the 2 boards is also displayed, and as an added bonus, you have a historical right here because you might not have caught it on the OLED display. Now you know how to get started with the Future Electronics Foxhound board. If you'd like more information, then please feel free to reach out to your local Future Electronics representative or visit us online at futureelectronics.com. Thanks for watching, and I'll catch you next time on TechVentures with Lazina.